You're welcome back from break. Let's continue from where we stopped. Let's consider example 2. Find the derivative of y equals x raised to the power 3 into 3x plus 2. The derivative, the y, the x, will be, when you differentiate x raised to the power 3, you get 3x squared. Now use the result to multiply the other term, 3x plus 2, plus differentiate the other term, 3x plus 2. The result is 3. Use that 3 to multiply the first term. So we have 3x raised to the power 3. In this case, when you open the bracket, you have 9x raised to the power 3 plus 6x raised to the power 2 plus 3x raised to the power 3. 9x raised to the power 3 plus 3x raised to the power 3, they are like terms. That gives 12x raised to the power 3 plus 6x raised to the power 2. This is the result. It could be simplified by factorization. It should be factorized, but in the option, it is not factorized. So let's look at our answer there. 12x raised to the power 3, 12x raised to the power 3 plus 6x squared. The correct option is option D. Let's consider example 3, yet under derivative of product function. If y equals 2x plus 2 in brackets all raised to the power 3, find the y dx. You will see this question is different from what you have been doing before. There is something about products. Look at it. If y equals 2x plus 1 times 2x plus 1, it could be written as 2x plus 1 all raised to the power 2. It's the same thing. So also this question, y equals 2x plus 2 in brackets into another 2x plus 2 in brackets into another 2x plus 2 in brackets. They are all products. Product is multiplication of 2 or more items together. So the result is what we call products. So that's why we still call this product function. So regardless of the fact that it has power, it's products. Do we understand? Because it's like writing 2x plus 2 in 3 places. 2x plus 2, then another one, 2x plus 2 in 3 places. And we say that is y. So do you understand now? But there is a method for differentiation of these for a JAMB student. You don't just gather your formula and say you want to be using formula on it. No, it will waste your time. So y equals 2x plus 2 raised to the power 3. The y, the x, we mean differentiate everything the way you see it. This is what I mean. The whole bracket, let's say the whole bracket is represented by b, and you have b raised to the power 3. Let's say the whole bracket is represented by b, and we have b raised to the power 3. How do we differentiate it holistically? We say the differentiation of this will be 3b squared. Do we understand? The same thing here. Differentiate the whole bracket holistically. The derivative will be 2x plus 2 as an entity raised to the power 2. Do you understand? Just like what we did here, b raised to the power 3 is differentiated holistically to be 3b raised to the power 2. The same thing, the whole bracket is taken as an entity. So differentiate it holistically, we have 3 into the brackets raised to the power 2 times differentiate the inside alone. What's the derivative of the inside alone? 2 times 2. Do you understand? So this times 2 will be 6 into 2x plus 2 raised to the power 2. And that's the answer. That is the derivative. So let's scan through and see what should be our answer? 6 into 2x plus 2 raised to power 2. Option D is the correct answer. Let's consider example 4. If y equals 2 minus x raised to power 3, or in bracket raised to power 1 over 3, find the y dx. What are we to do here? The y dx will be differentiate the whole thing holistically. So we have 1 over 3 into 2 minus x raised to power 3 raised to power negative 2 over 3. How? Let me show you. For doing that, we have 1 over 3 minus 1 in the power. 1 over 3 minus 1 gives negative 2 over 3. Do you understand? Negative 2 over 3. You must be very versatile in the little arithmetic like this. So, holistic differentiation of this is this. Times, differentiate only the inside. That's the technique for this type. Differentiation of the inside there is negative 3x squared, that is 3 times minus 1, that is here, then x raised to power 3 minus 1, that is x raised to power 2. This is it. We now have this times this. It means minus 3x squared times 1 over 3 into 2 minus x raised to power 3 raised to power 2 over 3. This 3 will take care of this 3. It will remain negative x squared into 2 minus x raised to power 3 raised to power minus 2 over 3. Is the option like, is any of the options like this? Negative x squared, 2 minus x raised to power 3 raised to power negative 2 over 3. The correct option is C, but let me show you something. In another question, the same question may not be left this way. This same question. In another year, JAMB may just change the mode of their answer. The same question, but different format of the answer. Instead of leaving the answer like this option C that we choose for our answer, see another way of representing this same thing. You may go ahead to represent this as minus x squared times 1 over 2 minus x raised to power 3 raised to power 2 over 3. I represent this 2 minus x raised to power 3 in brackets all raised to power negative 2 over 3 as in positive index like this. Do you understand what I have just done here? That's indices for you. So this multiply this will give us negative x squared over 2 minus x raised to power 3 raised to power 2 over 3 instead of this way. So answer could be left this way, somehow this way. So look forward to seeing or meeting something like this in your journey of mathematics in UTME. Let's consider example 5. If y equals 3x plus 1 in bracket into 2x plus 1 in bracket raised to power 2, find the y dx. The y dx will be differentiate the first term, and that will give us 3. 3 into 2x plus 1 all raised to power 2. You differentiate this, use to multiply this, plus differentiate the second term. Differentiation of this second term is more complex than the first one. So in it, you give it holistic differentiation first, which is 2 into 2x plus 1 raised to power 1 times differentiate the inside. The inside is 2. Differentiation of the inside is 2. So that is the differentiation of this. Now use the result of the differentiation to multiply the first term. That is times 3x plus 1 in bracket. So this is what we need to simplify. So this is 3 into 2x plus 1 all raised to power 2 plus 2x plus 1 in bracket raised to power 1 is the same thing as 2x plus 1 not having any power. So 2 times 2 is 4. 4 into 2x plus 1 times 3x plus 1. This dot means multiplication. So look at it very well, since there is nothing like this in the options as answer. So try to simplify. This term and this term you have something in common, like the HCF. So what the HCF of this term and this term? That should be 2x plus 1. So use the 2x plus 1 to divide this term. It will give us 3 into 2x plus 1. Plus, use the 2x plus 1 to divide this term. It will give us 4 into 3x plus 1. That is proper factorization. So this is 2x plus 1 in bracket into, open this bracket, small bracket. 3 times 2x, that's 6x. 3 times 1, that's 3. 4 times 3x, that's 12x. Plus 4 times 1, that is 4. So this is 2x plus 1 in bracket into 6x plus 12x. That should be 18x plus 3 plus 4, that is 7. 2x plus 1 into 18x plus 7 is our final answer. So, and that tallies with option what? 2x plus 1 into 18x plus 7, that is option C. Option C is the correct answer. Let's consider example 6. Find the derivative of square root of 2x minus 1. Why is square root of 2x minus 1 could be interpreted as 2x minus 1 all raised to power half. This and this are the same. Therefore, the y, the x will be, first give it holistic differentiation, and that will be half into 2x minus 1 raised to power half minus 1 times, differentiate the inside alone, that is 2. Differentiation of the inside of the bracket alone is 2. So we move forward by writing half into 2x minus 1 raised to power minus half times 2. These 2, we take care of these 2. You understand? So we have 2x minus 1 all raised to power minus half. That's the answer, really. But is it in the option like that? No, it's not in that format in the option. Therefore, remember in the indices that whenever you have x raised to power minus 2, it's the same thing as 1 over x raised to power 2. The same thing applies here. This will mean this 2x minus 1 in bracket raised to power minus half is the same thing as 1 over 2x minus 1 raised to power half. Is that okay? Just like this illustration. This is like that. But remember, x raised to power half is the same thing as square root of x. Also, this is the same thing as 1 over square root of 2x minus 1. Square root of 2x minus 1. And that will tally with which option there? 1 over 2x minus square root of 2x minus 1. That is option B, if I am not mistaken. Yes. Yes, that's option B. Option B is our correct option.